So today we will learn a new package, pandas. Last class we learned NumPy, and the NumPy, majorly we learned the NumPy array, and the NumPy array is homogeneous. Remember this, okay? It's a homogeneous. It's all of its data, but for pandas, this package is different from NumPy. So whenever you want to use it, you need to have this specific statement, import pandas. Normally we do as PD. Okay, you can also name it as others, but generally speaking, we name as PD. And this is for plotting. And at this point, we don't need to worry. And in pandas, there are majorly two kinds of data structure. One is series, the other is data frame. So let's first take a look at series. So series, it's a one-dimensional array. But be careful here. Before the array, we have this special way, we call it label. We never see this. Okay, but here there is a keyword called label. So this array is one dimension, but it's a label. So let's take a look. If you want to create a series, in this case, you can call PD series. And you plug in. What is this? Who still remember in Python? With the square brackets, within the square brackets, we have certain number of items separated by comma. What is this in Python? What does this represent? So we pass in this series constructor function with a what? What is that? That is square brackets? Forgot? It's a what? It's a list. Keep that in mind. So in Python, we learned different containers, different data structure. The first one we learned is a list. Then we learned what? What is that one can store a pair of value? Key value pair. Yes, dictionary, very good. What is that immutable one, but store number of items? Very good, tuple, yeah. What is the name for the one that can only store unique value? List can store duplicate value. Which one cannot store duplicate value? Set. It's called set. Okay, remember that. So we learn. But this one we pass in a list. Did you see? And when we display, you see it's interesting. It's not like a NumPy array. And then NumPy array, you only have the value. But here you have 0 and the value, 1 and the value, 2 and the value. So what is this 0, 1, 2, 3? Those are called label. So this is in pandas. Okay, for series, for data frame, we will see it has a label. This concept is very important as a label. That's a major difference between NumPy array. And here it says we can access element of series because you see here we have label, and generally speaking for list, for those container data structures, or like a NumPy array, we can always access through what? Through index. So you can access an item either using index here. We can also access through label. Be careful, okay, label. So let's take a look. Did you see here we create a series, and here you pass in what? You pass in a NumPy array. So you can also create data. You can also create a pandas series using a NumPy array. But be careful here. What does this index equal mean? That means for this series, you also give it a label. The label is not 0, 1, 2, 3 anymore. The default one is 0, 1, 2, 3. And here you specifically set the label as what? A, B, C, D, E, F. And then you can access. Did you see? It's not sir sub 1. It's sir what? Sub quotation B. Here you access that through label. Okay, be careful. We can also try. Then let's run. Did you see? It's the same thing. These two are the same thing. But over here, we access through label. Next one is an NBA CSV file. Let's see if I can find that CSV file. Okay. Let me resharing this file. This is that NBA CSV file. Did you see this CSV file is a plain text file? And the very first row, basically to list all of the column name. So the first column is name, the second is team, third is number, fourth is position, age, height, weight, college, and salary. And then following it, each of this exactly follow this definition. And we can also open this. Basically, this is also an Excel file. So let me stop this. And I reopen it in Excel. Then you will see it. Did you see? Basically, that CSV file is an Excel sheet. The first column is name. Second column is team. Third one is number and then position. And when you save this, then you can choose CSV file. Okay, so be careful. CSV file, you can also open it in Excel. Basically, it's an Excel file. And then let's get back to our Python code. So we just see the CSV file. We will use this through the whole semester. Okay, all of the machine learning here, the file, the data set, we are going to get them using the CSV file. So to open a CSV file in Pandas, Panda is very efficient. You just call the read CSV function. And here, we didn't provide the full path because anyway, the file and this program are in the same folder. So that's why I just provide the file name, okay? And generally speaking, normally, when after we open a CSV file, we want to take a quick look of what that file has. So you just call the data head. Then did you see it give all of the column name? Here is the index. So data frame, when you call read CSV, what it returns is a data frame. Data frame, this is a data frame. Basically, it's kind of like a two-dimensional array. But this two-dimensional is special. Each row, it has index. Each column, it also has a label. So both row and the column has a label. Okay, if you don't provide, by default, the label is 0, 1, 2, 3. But here, the column already labeled. Be careful here. And also, did you see this two-dimensional array is different from NumPy two-dimensional array? The data type is what? Is it still homogeneous? No, it's a heterogeneous. So it can have different type of data. Here you have string, here you have number, is it? So you can have different type. So it's a heterogeneous for Panda. That's why we say it's quite useful. And from this two-dimensional data frame, you can also extract single column for you as a series. Did you see? You get the first column name, then you just, how do you extract, access a column or row? You can do the label. So this is access through label. And what next one? So this is our data. Who still remembers this 3 colon 6 mean? What do we call that in list and in NumPy array? What do we call this? Who still remembers? There's a special name for it. Starting with S. What is it called? What does this call? What is it? It's called what? Slicing. Okay, keep that in mind. It's called slicing. Slicing is different from indexing. Indexing is doing what? Extract what? A single value. Slicing does what? Extract a range of values. And here, you want to extract from the third one to the 6th, but not including 6. So that's why you have 3, 4, 5. The result is out for you. Did you see? So this shows us how to do slicing, similar, okay, as NumPy and the list. And it's not so data pandas, it's more flexible because it's labeled data structure. Is it? So here we provide more way to do accessing. You can also call the data log function. So data loc, you can use label to also extract. So here, let's see. So this is a series. Be careful, okay, this series index. So 49, 48, those are not valid, those are index. A label. Okay, those are index. And when you do this :3, this :3 starting from where? Why before colon we don't have anything? What does that mean? Who remembers? Just :3, what does that mean? Because whenever you have colon, you should have two values, starting and ending. And why we don't have starting? Start from where? If we don't provide means start from the beginning. Okay, so here start from where? Start from 49 all the way to what? To this 3. This is its label, 49 all the way to 3. And if you use this loc and use the label, the ending one is included. Be careful, okay, here it's included. And then you can do like 3 to 6. Data, what is data? Data is this one. So this is data. So 3 to 6. And then that's this part. Did you see? So when you call the data loc, then you can insert the label. Be careful, here it's a label. It's not just a number, you can use the other thing as a label. We can also use data iloc. But data iloc, it cannot take a label, it can only take the index value. Like 0, 1, 2, 3. It doesn't take A, B, C, D, the ilocate. Be careful here. So this ilocate 3, then it's different. That means the first 3. Be careful, okay? Data iloc and data loc are different, two different kinds. You plug in data loc with label. You plug in data iloc with index. So label here is 49, 48, 47. The index is 0, 1, 2, 3. That is why here is index value. Okay, so again, we read that NBA CSV file. And a lot of time, okay, in machine learning, the raw data set has a lot of missing data. Normally, what we do is you can drop the missing data to handle, okay, to avoid error. So here, what you can do, you just call drop NA. And if you put this in place equal true, that means the original data will be updated. If you don't put in place, it won't impact the original data. Be careful. So the original data frame, the void value The null value will be dropped here. And you can also change the data type, like here it shows. So this S type, you can use it to change the value, because sometimes you may get a number, but those numbers are string. When you do machine learning, you cannot handle string. You need to use numerical values. So in that case, then you can change. Like over here, that salary, you change it to integer value. What next try to show us is that you can create a data frame using NumPy array with date time index and label the color. So here, let's take a look example. So here, so pandas has a specific function called date range. And then you can provide the starting date and how many dates you want it to have. And then here we have this data frame. So data frame, the value is going to be 6 by 4 array. And the index here will be this series. And the column, did you see it's a list? So for index, did you see in pandas, for index over here, you can specify using the dates, using the date series, okay. So this is the data frame. So here the row label is date, and the column label is A, B, C, D. And just here just shows us another way we can create a data frame. You can also use dictionary to create data frame. So here we have the dictionary, and then the dictionary key part will be column, and the row part of this data frame, we didn't provide the label, so it will use the default 0, 1, 2, 3. So this just shows another example. And we can also take a quick look of what this data frame, the top part and the bottom part, you can call head and tail. And if you want to know a data frame's index color, we can also call df.index. Then it will give you the row, and the column will give you the column label. So row label, you call data index. Column label, you just call data column, okay? And to retrieve the value, you just call the data value. There is a function called describe. The describe will also give you some basic statistic information about this data frame. So like the number of items in each column, mean value, standard deviation, minimize value, maximize value, 25% quantile, 50% quantile, 75% quantile. Okay, so next, let's see. So this is the data frame, DF. So we have this data frame, and you can sort by index. So here's a sort index. Which index? Not 0, 1. 1 means what? Column. And it's ascending? No, it's descending. So after you call that, did you see you can rearrange this data frame. You reverse the order by the column, but this is by column index, okay? We can also do sort by value. And if you do sort by value, you need to specify which column. Here then it says, okay, by column B, you sort value. So only column B is sorted. Column A, column C, and column D may not. And what next is data frame, how to access. So here we already learned data lock and data ilog. And you can also call data at and data I at. So for data frame DF, if you recall, this is DF. This is DF. It has 4 columns. If you just want to extract a couple of columns out, then you can put the column index, the column label in a list, and then you plug it in to this DF. Then you can get both columns. And we can also do slicing. And this slicing is through index. Similar, you can also use label, row label to do slicing. So either way will work. Okay, so what the next one shows us is we can also selection by label. So anyway, so this is a data frame. And this data frame, the row is labeled by this name. Then let's see. Then if you do, like you specify the row label, then it will give you all of the row information. So here, the second row, you provide the label of the row. So this is quite useful, okay? What next? Let's see. We have this data frame, and we have that dates series. And the dates 1 is this one. And if you do the look and you pass in the first date, then you will get its value, okay? Next one is about multi-axis, selecting on a multi-axis. And so here, for the row, did you see for row, we select all of the row. For column, so you can use label to select a column. Very, very useful, okay? And you can also do data lock. So similar. And if you use data at, it's quick, okay? It's fast access. So at is quite efficient for accessing. So you can also call data at and pass in label name. if you do iLog, you cannot pass in label. You can only pass in index. Be careful, okay? So same thing. The data I add only allow index, not allow label. So here we have learned 3 ways. The first way is just it's just direct. You put label. You can put like row label, column label. Okay, you can put row label, column label to a data frame. So this is the first option, using label. And the second option, you can do data look. Data look still take row label and the column label. Okay, and here be careful, okay? This row label can be single value, can be a list, can be what? Can be a slicing, can be a range with colon. Is it? So if you just want to get a single value, you just provide it. If you want to get multiple, but not in sequence, you provide the list. But if you want to get a range, you use colon. So the row label, column label can be any of this. Okay, so that look, and the third choice is df.add. Same thing, you can do row label, column label. Okay, so over here we discuss different ways. But be careful, okay? You can also do what? Row index, column index. And you can do iLog, then with index. Be careful, okay? I shouldn't just say index, I should say index value, index number. So here similar, it's index number. It must be number. And you can also df.I add. Then it's got to be index number. Index number. Be careful, okay? Here we learned multiple ways to access. Next one says you can also do Boolean index. So this is quite useful. You see, you just say, okay, which specific row or column, meet a certain condition. This here says, oh, all column A greater than 0. Then I extract the data out. So here, only A, value from A is greater than 0. And you said, okay, is df greater than 0? If it is not greater than 0, then it give you return what? Return a null value, NaN. So it's a null value. So this function is also quite useful. A lot of time you just want certain data out. Then you can use this is in. So what over here we have a data frame df. And we add a new column. Okay, we add a new column. And what this one means, okay, in this column, we only choose 2 and 4 out. Otherwise, we are not going to choose. If the value is not 2 or 4, we are not going to choose it. So then you can use this is in, okay. Next is set setting. So how do we do it? So here we have a series created. And this series index, we use the date, time. And you can set a new column with this series. Is it? You can do this. And then did you see the first one doesn't match? Because over here start with January 2nd. So when you add it to the column, then the first one, because it doesn't have any value, so it's provided with that. Oh. What is the next one? You can also call the data add to reset the value. You can also use IAdd. The IAdd, you need to use position number, not a label. So be careful here. Okay, so let's get this question. What does this mean? Data log, colon, comma, then D. What does that mean? What does that colon mean? So before comma, that colon, what does it mean? What does it mean? It means for all of the rows. Is it? Because it didn't specify starting and ending. If it didn't specify starting and ending, that means all of them. Everyone. So every row is included. Which column? Column D. So from column D, all of the value is going to be assigned with this new value. That's what this means. And we can also apply the where operation. So here, you just reassign as it meet certain conditions, then you reassign the value. So that's easy to understand. And how do we handle with missing data? We already see as drop NA. And the reindex, we can also reindex. So here, that DF, previously we have its index. Now if you want to reindex, you can call reindex function. Then you specify what the index, what the column. Okay, so this is the use for reindex. And the drop NA. And drop NA, you can also provide a condition. It's any or all or something. And sometimes for missing data, we don't want to drop. We still want to keep them. Then you can fill in with some value. So generally speaking, we fill in with mean value. And here it's just fill in with a specific value. And you can also check which one is null value. So it will give you true, false. Okay, and the operations, and it says operation in general exclude the missing data. So a lot of time we want to mean, sum, count, that those operations. So if you do df mean, what does it mean? So this is df, that data frame. And you call it mean. And you didn't specify it by row or by column. If we don't specify, it will do row summation and then average. So it's add all the values by column, but all from rows, from each row. So that's why here you have the, here for each column, we have a mean value. If you specify like 1, then it's by row. So it's do value addition from column and then divide by the number of columns. And we can skip that. And you can also apply certain function to the data frame. So did you see here? So it says apply cumulative summation. This is cumulative summation. That so you are going to do cumulative summation of what? So this is the original data frame. You are going to, we didn't specify the axis. So by default, it's going to do cumulative summation along column by row. So that's why here it has, and the third one, did you see? It's the addition of 1.13 and negative 0.93. It's the addition of the previous one. And it keep doing this. So this is cumulative summation. And for the apply, you can also plug in a function. And lambda expression is a function. You define this lambda. This is a function without a name. And for this function, what it does is find the maximum and minimum and then do subtraction. That's what this function does. So it find what? It find the maximum value along A, minimum value along A, and then subtract. Then it's applied to A. For B, it does the same. Find the maximum, find the minimum, do subtract, and apply to B. So this is what this function does. It didn't specify which axis, then by default, remember, it's for row. It's row-wise. And here, The value count is for histogram, okay? It's count how many values for each one. As string method, we are going to skip because we already discussed string last class. The next one is discussing about multiple data frame. How do we concatenate them together? So here we have a data frame. It's 10 by 4. What does this mean? This df colon 3. df colon 3 return you what? Return you this section. Is it return you this section? And then 3 to 7 return you this section. Three to 7 return you this section. And then 7 forwarding. And you can call concatenate and plug in, because this is what? This is a list. And within the list, it has 3 data frames. Be careful, okay? So here, the list has 3 data frames. And then you can just call concatenate. Next, we have these 2 data frames. We have this data frame. We have second data frame, df and df1. And we call concatenate. We have 2 data frames. You put 2 data frames in a list. And you concatenate. And here is a concatenate the axis. The axis is 1. 1 means you expand row column. You make it wider. Okay, axis 1 is mean column. You expand the column. But we do what kind of join? We do inner join. Inner join only take common values. So let's take a look. The first one, you have Jade, Praise, George, and Bob. Second one, you have George, Bob, Drew, and Stephen. Is it? When we do inner, the common one we have is going to be George and Bob. This 2 and 3. The index, the position, inner join, both have the 2, 3 index. So you can only join those 2. That's why, did you see the result? We only have 2, 3, not others, because it's inner join. Inner join looks for what? Looks for common index. Look for common index. Be careful here. And the next one, it do concatenate by column. It didn't specify inner join or outer join. It by default it's outer join. And it's not going to do sort. That's why, did you see? It's including everyone here. Including everyone. For the first 2, it doesn't have like name, age, address, qualification, salary, then it will fill with net, with the null value. And you can also specify the axis. So this join here says we use SQL style merge. Okay, it has nature join. Nature join means keep only row that match from the data frame. Full outer join, keep all. Left join, then only need to specify how as left. And the right join, you need to specify how with right. So let's take a quick look. So we have these two data frames. These two data frames. Then we call merge. Merge with a left to right. It only see on key. And it didn't see it's left join or right join or outer join. So it's only on key. So if the key is same, you're going to keep it. So that's why over here you get this result. Be careful, okay? Next one, let's see. We have these two data frames. Then you do merge. Merge also on key. Is it? So key is full bar. That's why you have this result. Next one, let's take a look. We have these two data frames. Then we call merge. This time we merge we specify two index label. Yeah, you can also do that to do merge. Both on key and key one. So we didn't specify, that means it's what? It's inner join. Only look for common ones. Common one, we have what? K0, 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 K2, K0, K2, K0. That's why, did you see the result will only have K2, K2, oh, K0, K0, K2, K0. Only look for common ones. So here you specify how as left. So if it is left, then the left data frame, here this data frame will be kept as its original. So all of the keys will be kept. And the right will be joined with the DF1. Only the matching one here. And here you do outer, so then that's include everyone. So not just looking for common ones. So everyone. Everyone, if there is no value, then you just provide the net. So that's the trick part. Inner only look for comments. The next function, so we have learned concat, merge. Now you can also do concat with join. So join. And the join is the function of a data frame. So you specify the first data frame, then you join the second data frame. So this is kind of like when you call merge, do left join. So every index from DF will be kept. And DF1, only matching DFs will be kept. If it is not matching, it will be dropped. So we have K0, K1, K2, K3, and then under the DF1, we have K0, K2, K3, K4. These two are not in DF, in DF1, in DF. So did you see? Those two will not those two. Sorry. The last one is not in DF. So did you see? The result will not contain the last one because it's based on DF. Because it's DF's join. If you do DF1.join, it's going to be a different story. You can try it, okay? And you can also specify how as the outer. If you specify how as the outer, then did you see the last one is included? You can also specify on which label to join. So here you have these two labels, is it? Then it will join with the label. And for inner, then it's the same. It only look for the common ones. And for this one, it's a little bit more interesting. For the DF1, the row label, we only have one called key. But for the second data frame, be careful here. Here we have multi-index. So in Pandas data frame, it is also allowed to have multi-indexing. That's quite useful, okay? So here, let's take a look. We have multi-index. Did you see the row has two, each row here. Be careful, each row here has two index labels instead of one, as what the previous two labels. And then you call join with inner, so it only look for the common ones. That's why it has the common ones. And how do we append the rows to data frame? So that's pretty straightforward. So you have a series, you just call append. So that will append to the end. Okay, the next one is quite useful. Do grouping. So this is our data frame. And it's a closed loop. It's used. So you want to group by full, to full, to full. And bar, to bar, to bar, and to bar. For this one, it's a full, full, and a two. So we need to add this. And for this one, it's bar, bar, bar. That's for the big part. Bar, A, and star, B. Okay. Did you see? They to give you this result. And for B, it cannot do that. And you can also try, go home, you can also try group by B, what you get. And did you see, you can also do group by A and B. This is more interesting. So here, group A and B, but it will be so it does look something based on this kind of group. This is very, very good. Y function. That is I. And we can also do reshaping. And here there is a concept called unpacking, iterable. Okay, using the zip function. So here we have two Python lists. And if you call zip, what you're going to get? You're going to get a pair. So be careful, okay? So you have this one, this is you want to do pair. What is the return? This is return iterable. And the iterable normally you don't directly convert it to this. Then you have in this one. This is quite useful because sometimes you want to do the dictionary. Okay. And sometimes you have this zipped data. You want to unpack. Then you can plug in. So here you want to get into that. So this is in this. But within the so you can add in some. Then this for this one. This is action. Okay. Then you get off the name and on the format. That's their original data. So what over here we have is you have the zip, that within the zip, you have two lists. You have two lists. So you're going to do the pair, convert them to tuple. Be very careful here. This is interesting. See the difference, subtle difference between this one and the previous one? Take a close look at subtle difference. This and this. Here, within the zip, you have what? You have two lists. Two lists has to be like this function. You have what? You have a list. You take the list, you have two lists. So the counter, the bigger list, have two sub-lists. The list, the icon. Okay, That's why here we want to unpack the stuff. And then we do set. Okay, so anyway, so that's next one. We have the data frame. And this time we want to have multi-index. And this multi-index is from the tuple that we just create. And this multi-index, the first one, we give it a name. The second one, we get a name called the first and second. And then we build a data frame. The index will be that multi-index. This is column. Careful here. This data frame, this is for multi-index. You have step 1, step 2. You have 2 levels. Okay, be careful. This is column. Okay. So when you do like a DF do slicing for it, will take the first 4 rows. Okay, and what the next one try to show us is the column. For column, you can also have multi. So you have 2 levels. On the bottom, on the back, you have 2, on the foot, you have on the top. So this is multi-level indexing. And when you call stack, did you see? When you call this stack, so make it call stack. So it is the row multi-level index. Convert column level multi-level to row level. So that's why it's not a thinner. Slim. Okay. And you can also specify which one you want to do thinner. You see, you can specify. And you can also specify both. Then in this case, you kind of do flattening. This is called flattening. Okay, and you can also unstack. Unstack is get column, multi-level column, or multi-level row to column. So you add more level of column. So different way. The last one, this is also very, very useful. Pivot table. So here we have this table, this data frame. If you call pivot table, you need to specify regarding which column here. So here is regarding column D. And the index is AB. Okay, and the column is for C. So let's take a look. So this is the original data frame. D, you have value. A, B, C, we only have word. Is it? So we are going to do pivot table. So pivot table by default, we didn't specify, so it's do mean calculation. So mean calculation here, what is index? Index is going to be AB. And the column is going to be C. And using value from column D. So all of these values are the mean values. So this is regarding pivot table, okay? So quite useful. And time series, I don't think we need to do. Oh, the last one is categories. Categorical data. Okay, so this is also very interesting. So here we have this data frame. Is it? So this is our data frame. And we said with that raw gray, we define the type as category data. Be careful, this is the category data. And then you can rename the category data. So you see, we change A, B, C, D to very good, very bad. It will do automatic mapping for category data. So it's quite useful. You can set a category, is it? And then it will provide you with the category. And we can also even do sorting by the category. And you can also do group by category. And it gives you the number for each category. And for the plotting, we don't need to do that. And the next is the data frame you created. You can also write back to a CSV file. So you just call to CSV file. Okay, to CSV. And the last is HDF store. So HDF file formatting. So this is a hierarchical data formatting. And we are not going to use it, but just to give you some basic idea. Okay, so a lot of time, very large amount of structured data. If you want to store it and processing it, you can use HDF file formatting. Okay. So that's